This $27 sand battery could heat your cabin through winter without propane. The heating industry spent decades convincing people that surviving winter meant depending on fuel trucks, rising utility bills, and machines that break at the worst possible time. Meanwhile, hidden inside old farmhouses and quiet rural workshops, another system kept working almost unnoticed. No roaring furnace. No endless wood chopping. No gas line running across the property. Just sand holding heat long after the sun disappeared behind the trees. And the craziest part is how simple it really is. A wooden bench filled with heated sand can quietly warm a cabin through freezing nights using only a few hours of winter sunlight. It sounds like something pulled from an old survival journal buried in a forgotten attic. But the science behind it is absolutely real, and versions of this system have quietly existed for generations in rural America. When winter hits hard, people start thinking differently. You stop caring about luxury and start caring about control. You start watching the propane gauge like it is a countdown clock. Every gust of freezing wind suddenly sounds expensive. That is why this old thermal trick feels so powerful once you understand it. It takes heat storage back to basics. Sand is one of the best natural materials for storing heat. Scientists call it thermal mass. That simply means it absorbs energy slowly and releases it slowly. Dry silica sand can hold massive amounts of heat without breaking down, burning, or wearing out. Once heated, it behaves almost like a natural battery. The setup itself is surprisingly straightforward. A black solar collector sits on a south-facing wall outside the cabin. Sunlight hits the collector and heats metal tubing running through it. That tubing carries warmth into a sealed box filled with sand. The sand absorbs the heat during the day, then slowly releases it back into the room through the evening and overnight. No flame. No smoke. No loud generator humming outside the window. Just stored sunlight. What makes this even more impressive is that winter conditions actually help the collector work better. Most people assume solar heat only works well in summer, but cold air improves the temperature difference between the collector and the outside environment. That larger temperature gap increases heat transfer efficiency. Even on freezing January days, a properly angled collector can become extremely hot after only a few hours of direct sun. That heat gets pushed into the sand chamber where temperatures can climb well above 200 degrees Fahrenheit. Once sunset arrives, the sand slowly releases that stored warmth for hours. A properly built bench can hold enough energy to provide heat through most of the night in a small cabin or workshop. And unlike modern heating systems packed with electronics, this setup has almost nothing to fail. That is part of why old-school builders trusted it so much. The design uses basic materials almost anybody can understand. A wooden insulated box. Copper tubing. Dry silica sand. A black metal collector. Some insulation. That is basically the entire system. Many early builders used salvaged materials to keep costs almost unbelievably low. Old patio doors became solar collector glass. Scrap lumber became the bench frame. Salvaged copper tubing came from discarded appliances. Some homemade systems reportedly cost less than $20 using mostly reused materials. Even modern builds using new supplies can often stay under $150. That is less than many families spend heating their homes for a few days during deep winter. One forgotten trick from older solar research makes the system even more effective. Powdered graphite mixed into the sand dramatically improves heat movement inside the thermal mass. At roughly 5% by weight, graphite helps spread warmth evenly through the entire bench instead of allowing heat to concentrate around the copper tubing. That means the system charges faster during sunlight hours and releases heat more consistently overnight. Builders who tested graphite-enhanced sand systems reported significantly longer heat retention times, sometimes stretching close to 20 hours under the right conditions. That difference becomes critical during cloudy winter stretches when every bit of stored warmth matters.